Okay, lesson 2.6 in your textbook, 2.5 in your notebook, solve factorable polynomial inequalities. So it's essentially all the same skills and strategies, but this time instead of the solution, let's take this, instead of a solution being the exact point at which the function equals 0. So let's say this was like -1, +3, +5. Instead of your answers being just x equals this, x equals that, x equals that, it's going to be a range. So an inequality doesn't have an equal sign in it. It has an inequality in it, like a greater than or a less than or a greater than and equal to or a less than and equal to. And in that case, your answer will be a whole range, such as where is this polynomial greater than 0? Where is p of x greater than 0? Well, it's greater than 0 to the left of -1. It's greater than 0 between 1 and 3, and it's greater than 0 to the right of +5. And so we'll be expressing our answers as inequalities or bracket notation or number line. Get right to it. Example 1. Solve each inequality. Show the solution on a number line. So in example 1a, we have the inequality. It's quite simple. X minus 8 is greater than or less than 3. And the number line will indicate our answer. Where is that true? Well, we just use our same old algebra skills, but we keep an inequality in there. There's a couple of rules we're going to learn about inequalities along the way, but we're going to add 8 to both sides, and you get x is greater than or greater than or equal to 11. So now, in order to indicate that on your number line, because there's no numbers on your number line, it's really easy. You're just going to pick one of those lines to be 11. It's going to be a solid dot because our inequality includes 11 and any value greater than 11. So we're going to trace that number line to the right and put an arrow. So I've indicated that in purple. Now we're going from 11, including 11, and beyond. And that's how to indicate it on a number line. B is -4 minus 2x is less than 12. So you already can see that in this case, it's not going to be inclusive of the value on the opposite side to the variable. Again, algebra skills, we're going to add 4 to both sides. And at this point, we need to make a note that you are not allowed to forget. Because here, what are we going to do? We're going to divide both sides by -2. And when you divide when you divide an inequality, both sides of an inequality by a negative number, you flip the sign, okay? So when you multiply or divide both sides of an inequality by a negative value, comma, you must flip the inequality, or I'll say reverse, be all official. You must reverse the inequality. So what we end up with here is x, reverse the sign, is greater than, or sorry, not or equal to, is greater than -8. Okay, and we can test that that's true if we're not sure why this concept makes sense, but let's say a number greater than -8 would be, say, -5. Okay, if we put -5 in here on the left, we'd have -2 times -5, which would be +10, which is less than 16. Okay, If we picked a number that was less than, so if we didn't flip our sign and we picked a number that was less than -8, say -10, we'd end up with -2 times -10, which is +20, which is not less than 16. Okay, so multiplying or dividing by a negative number in an inequality results in reversing the sign of that inequality and displaying on your number line. Again, you have no numbers on your number line, so you pick any point to be 8, -8, and you indicate that by an open circle because it does not include -8, and we need all the values greater than -8. So your number line will look like that. In example 2, we get a little bit more complicated. There are going to be multiple cases to consider. So in A, we have the factored expression on the left side of the inequality, x plus 3, 2x minus 3. So there we're giving you this step by step, right? You're going to have to be factoring later on in order to get to this step. But in order for this situation, this expression on the left to be greater than 0, what does it mean for something to be greater than 0? What's another way of saying greater than 0 in one word? It starts with a P. Positive. Okay? So we have two factors. We have f times f. They're different factors, I guess, f1 and f2, equals a positive value. Okay? So what has to be true about factor 1 and factor 2? Good. So we're going to consider all cases. In order for this statement to be true, either both factors are positive or both factors are negative. So case 1, in case 1, we could say x plus 3 is positive and 2x minus 3 is positive. Okay, so now we're going to work that out and we'll get a solution here. Over here we just subtract 3 from both sides. We get x is greater than -3. Over here we get add 3 to both sides and then divide by 2. We get x is 3/2 or 1/2. Now, this is a really important part to learn. So I'm drawing this little number line, and what solutions we've kind of come up with, key points we've come up with, are a value of -3, x greater than that, or is the range that we're working on, is the domain that we're working on, things greater than 3.5. But what we have to do here is choose the value, the set of values that will satisfy both of these inequalities. What am I saying? Well, let's say we take the value of -3, okay? -3 doesn't work because it's not inclusive. So why don't we'll think about -2. Is x greater than -3 if x is -2? Yes. But is x greater than 1.5 if x is -2? No. So the values in this range do not actually satisfy the case in which both of these are positive. The only values that make both of these inequalities positive and result in two positive factors would be the values to the right of 3/2. Does that make sense? So like the number 2, you could put into inequality 1 and inequality 2, and they would both be true.
Well, if both are negative, it's still going to result in positive numbers.
Correct. But the values between -3.5 result in this guy being positive and this guy being negative. Okay? So the only values that satisfy this case are the values to the right of 3/2, because 3/2 satisfies both of these inequalities. Okay, good. So that was case 1. That was getting a positive and a positive. So what do we need? A concluding statement there. X greater than 3/2 is included in x greater than -3. So the solution is x greater than 3/2. Basically, in each solution, when you combine these cases and you're deciding which one is the solution for both, you're going to take the more restricted solution, the more restricted domain, okay? The smaller domain. Case 2. In case 2, we need 2 negative factors. So x plus 3 is less than 0, and 2x minus 3 is less than 0. Now, when you get good at this, you start to notice that a lot of the work for stage 2 is already done. You basically just need to flip the sign. So here we subtract 3 from both sides. So we have a solution x less than -3, and here we're going to add 3 to both sides, then divide by 2. We end up with x is less than 3/2. Now we think about this again a little more quickly on our number line. We have the same number line. We have 3/2 here, and we have -3 here. But now we're looking for all the values of x that are less than these. So if I chose a value that was less than 1.5, but bigger than -3, like 0, it would result in one of them being true and one of them being false. So what I actually need now is all of the values to the left of -3, because we'll write the same thing. Since x less than -3 is included in x less than 3/2, the solution is x less than -3. Any value to the left of -3 will satisfy both inequalities. Now, in our concluding statement, we need to combine the results. Combine results. We have a solution in case 1 and we have a solution in case 2. So we'll see what those things are. We end up with, here we have our solution for case 1, x greater than 3/2, or the solution for case 2, x less than -3. So how would we express that on a number line? Might look something like this. We've got x to not inclusive, so we've got an open circle, x to the left of -3, and we have 3/2 here, exclusive, and x to the right of 3/2. Okay, that was one method, the method of considering all cases. We have another method, and it is just use intervals. So in the case of A, which we're working on, which is x plus 3 times 2x minus 3 is greater than 0, it's already given in factored form. So we already know where those key values of x are. We know what the zeros would be. Okay, we know where this expression on the left can equal 0, which is where it's going to change from positive to negative each time. So all we need to do is identify the roots. the roots are, and we've done this work in the previous section, but you don't really need it for this because you know how to do this. So the roots are x equals -3 and x equals 3/2. Okay, that's the zeros of each of these factors. That's the values of x that will cause the left side to be 0. So that's the roots of, and you really wouldn't say the roots of the inequality. You would have to say the roots of the corresponding equation. So the roots of the equation, which would be the same thing on the left and the same thing on the right, but it would have an equal sign in the middle. So the roots, I'm actually going to add that because what we wrote here is actually wrong. The roots of the equation, what is the equation? It's x plus 3, 2x minus 3 equals 0, are x equals -3 and x equals 3/2. So now we take those roots and we use them to break up a number line. All right, so we've got a number line, and what do we know? We've got -3 here, and the other key value that we have is 3/2. We'll put that there, which puts 0 right around there, just for reference. And all we want to do is break it up. Use a dotted line if you like. Add our 2 zeros. And now what we want to do is test values within each interval. So basically what we know is if the function itself is changing from positive to negative at this point or at this point, then between those 2 points, it's going to be positive or negative for the whole interval. And over here, if it's positive or negative for one of these values of x, it's going to be for all of the values of x in that interval. Same thing down here. To the left of -3, it's going to be either positive or negative. It's not going to change anywhere in this range. So if I pick a test value here and it's negative, then this whole interval would be negative. Okay, so what we're going to do is test values within each interval. Test values within each interval. So we do this nice, neat, and organized. For x less than -3, that would be our interval here to the left of -3, from -infinity to -3. For this value, for this interval, we can choose any value inside that interval. So you'd go with the next easiest whole number. We'll test x equals -4. All right, so we're going to take the left side of our inequality and we're going to sub in x equals -4. So we've got -4 plus 3 times 2 times -4 minus 3. First bracket reduces to -1. Second bracket is -8 minus 3, which is -11, which equals +11. Is that greater than 0? Yes. Okay. Since 11 is greater than 0, x less than -3 is a solution. Okay, you see how that works so far? We separate it into our intervals. Within an interval, it's going to be any value within that interval is either going to be a solution or not going to be a solution, and the rest of the interval is going to be the exact same. So we tested a value inside that interval, found out that it's 11, which does satisfy the inequality. Therefore, everything in this whole range is a solution. Okay? Now we can test our middle interval for, and here check out the interval. It goes from -3 to 3/2. What would you like to test? If you can test 0, test 0. It's easy. Okay, So here we're subbing in 0 everywhere we see an x in the left side of our equation, which leaves us with 3 in the first bracket. And maybe I should actually write what I'm doing so that it's easier for you. 0 plus 3 in the first bracket, then 2 times 0 minus 3 in the second bracket. That gives us 3 times negative 3, which gives us negative 9. Negative 9 is less than 0, therefore not a solution. This range is not a solution. I'm not going to do the whole next step. I'll just write out what we would do. For x greater than 3/2, what would you choose? You'd test 2, and you would find out that x greater than 3/2 is a solution. Okay, that is another way to do it. That is different from the consider all cases. You simply visually split up into your intervals based on the factors. If you don't have them, you need to find them. And then you test a value inside each interval. Okay, in B, we're going to apply the same methods in order to solve it. We're going to consider all cases. So method 1 in B, consider all cases. Now, the inequality given is a little bit more challenging. It starts with...
Factor this first?
Oh, yeah, sorry, we need to factor it first. So we've got... We're going to factor negative 2x cubed minus 6x squared plus 12x plus 16. We can do that using the factor theorem. I'll do a quick debrief on that since we didn't all get it on the quiz. But basically the factor theorem says that ax minus b is a factor if and only if p of b over a equals 0. Okay? And in order to get those values of b over a, in order to test for 0, we get b from the factors of the constant. So b could be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. The values of a come from the factors of the leading coefficient. So it could be plus or minus 1, plus or minus 2. So my values for b over a that I could sub into the polynomial and evaluate, the options there are plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. That's all of the options b over a that it could possibly be without repeating. So now I go ahead and I test some of those values, okay? I'm not going to do this and find it out, okay? But if you used the factor theorem and you tested some of these values in there, eventually you'll choose a value that gets you a remainder of 0. And one of them is p of negative 1. P of negative 1 ends up equaling 0. Therefore, x plus 1 is a factor. So then you would use long division or synthetic division in order to divide out the rest. Maybe sum and product, maybe factoring by grouping, however else you can factor it all the way through. And what you end up with is, and I'll just go ... after factoring. After factoring, we end up with an inequality of negative 2 x plus 4 times x minus 2 times x plus 1 is less than or equal to 0. Okay, so there we've taken our inequality, we factored the left side. All right, so now in order to determine what the solution for this inequality is, the domain of x values that make this statement actually true, we're going to consider all cases. Well, it's less than or equal to 0. So what has to be true about the multiplication of factor 1, factor 2, factor 3, and factor 4? Well, it has to be true that when you multiply it all together, it ends up being either 0 or a negative value. Okay? So there are a whole bunch of cases to figure it out. This is only going to be negative when one of these factors is negative, or 3 of these factors is negative. Correct? 3 negative factors would result in a negative. It will also be true if any of them is 0. Okay? So basically, in order to incorporate 0, you really just keep this as your inequality that you're working with. So here we go. The product is negative if 3 factors are negative and if only one factor
No, because there's a equals -2.
is negative. Right. This is one of our factors.
Oh, okay.
So basically, this is one of our factors. This one is always going to be negative. So then we're reduced in our cases in the work that we have to do. If 3 factors are negative, that means 2 of these guys are going to be negative, or none of them are going to be negative. Okay? But none of them being negative, that's easy. They're all positive. That's just one case. But for 2 of them to be negative, there's actually 3 cases. It could be these 2, it could be these 2, or it could be these 2. Okay? So here we go. We're going to list all our cases. We'll list them one by one and then consider them. So this is where you have to kind of keep it organized in your head. Okay? All of the cases. Case 1. And maybe we'll actually list all of the cases and we won't do necessarily all of the work. But case 1, the case where all of these 3 factors are one thing that we can do to make this easier on ourselves is we can consider -2 as part of that first factor. Okay, so that can be one of the factors, that can be another factor, and that can be another factor. So now we need 3 negative factors, and we only have 3 factors. So in case number 1, if we're going to write it out, we would have -2 times x plus 4. That's our first group. That's going to be less than or equal to 0. Our middle factor, x minus 2, is also going to be less than or equal to 0. And x plus 1 is going to be less than or equal to 0. Okay? When we work this out, we can divide both sides by -2 here. And it's important, it's not going to change the 0, because 0 over -2 is going to be 0. But what is it going to do? It's going to flip the sign. Okay? So we've brought our negative to the other side, which means we're flipping the sign. And then we subtract 4 from both sides. X is greater than or equal to -4. Here we have x is less than or equal to 2. And here we have x is less than or equal to -1. So now we need to look at those solutions and say which solution includes all of the other solutions. So we can do this by drawing a number line. Okay, we're going to draw 3 number lines. 1 right on top of each other. Again, you're not going to get a lot of practice with this because we're almost out of time, but if we have those number lines right on top of each other, and I notice that we have our key points at -4, at -1, and at 2. It doesn't really matter how you draw those, but basically what we want to do is we want to use each line to indicate the solution for one of these inequalities. So in this inequality here, we have x greater than or equal to -4. That includes -4 all the way up. Then you have x is less than or equal to 2. That takes 2 and all the values all the way down. And then we have x is less than or equal to -1. Starts at -1 and goes all the way down. Now our goal is to choose the values of x that satisfy all of the inequalities. Where is it that all of these statements are true? Well, that only happens between -4 and -1.
And then it's going to be negative.
Okay? So this is true. All three of these are true. And therefore the original statement is true, where x is in between -4 and -1. So therefore, -4 less than or equal to x. Sorry, I'm writing that. Nope, that's right. That's right. -4 less than or equal to x less than or equal to -1 is a solution. Okay, I'm not going to show this part for the rest of the cases, but we will jot down what the other cases are, and then you would end up doing the same thing with those. So case 2, I don't want to use that. Case 2 would be the case in which there is only one negative and 2 positives, and there's 3 of those such cases. So we could write them out. We've got -2 times x plus 4. Let's make that one negative, less than or equal to 0. And then the other 2 have to be simultaneously positive, greater than 0. Okay, so we would solve each of those inequalities. We'd draw our 3 number lines. We'd write the solution for the first one on the top line, the second one on the middle line, the third one on the bottom line, and then you'd see where all 3 lines get overlapped, where all 3 lines are solved. Okay, it might be that there doesn't exist a spot. Okay, that's an option too. If you draw your 3 number lines and there is no overlap, that's a possibility. Then that case has no potential solutions. Okay, and the next one, we're going to copy down the exact same left sides, but this time your first one is going to be positive, and your third one is going to be positive, but your middle one is going to be negative. Again, I'm just setting these up, not solving them. And the last case that we could talk about is where your first factor is positive, your second factor is positive or equal to 0, and your third factor is negative or equal to 0. And again, for each of those, you would draw your number lines, you'd solve the inequalities, draw your number lines, see where they line up. And then at the end, you would combine all of those solutions and to see what it is. Okay? In this case, this does not result in any solutions, and this one does not result in any solutions. So the only solutions here are going to come from case 1 that we already did and case 2, and then you'll combine those results and you'll get a solution of, I'm going to write it down, solution of -4 less than or equal to x less than or equal to -1, or x greater than or equal to 2. Okay, for example 2b, we're going to do the exact same problem, but this time we're going to use the second method, which is using intervals. We've already factored it in method 1, so I'm just going to write the factorization of this inequality. We've got -2 times x plus 4 times x minus 2 times x plus 1 is less than or equal to 0. And we found out that the roots of the corresponding equation are, so the roots are x equals -4, x equals 2, and x equals -1. And so doing that, we can break the number line into different sections. Now, I'm going to draw the number line just over here so that we can see we've got -4, -1, and 2. So, yep. And so you can clearly see the sections that we have. Okay, and we can write what those intervals are so that we know what we're talking about. We have everything to the left of -4, that's x less than -4. Then we have the interval from -4 to -1. Then we have from -1 to 2. And then we have x greater than 2 all the way to the right. So one way to do this is to arrange it into a, to pick test values for each interval to see where you have positivity, negativity. What I'm going to do this time, we've done an example like that, so you can use that strategy. What I'm going to do this time is make a chart, okay? So we've got an interval factor chart here. Basically the rest of your page is going to look like this. So maybe wait until I draw a little bit of it and then you can copy it down. So going down, we're going to have all of our factors, and going across, we're going to have all of our intervals. So the intervals then, as we've just discovered, are x less than -4, and then we're going to have another column for what happens when x equals 4. And then we have our next interval from -4 to -1. We want to see what happens at x equals -1. And then we have -1 to +2. We want to see what happens at x equals +2. And then we've got x values greater than 2. And on the left side, we're just going to list each of our factors. So we grouped this -2 bracket x plus 4, x minus 2 as a factor, x plus 1 as a factor. And then we want to say what happens when this whole expression is together, the product of these factors. So -2 times x plus 4 times x minus 2 times x plus 1. Okay, this looks like a lot of work getting it set up, but once you're set up, it becomes fairly simple to accomplish. All right, what are we going to do in each of these boxes? We're just going to tell whether the value of this factor is positive, negative, or 0 in this region. And we're going to do that all the way along, okay? And sometimes we won't need to do anything. It'll be really easy to tell, but because we know it's changing from positive to negative as well at each point because each factor is order 1. But here we go. So all we do is mentally, this is kind of what you were talking about a little bit yesterday, I think. You just take a test value from -5, okay? -5 in this factor gives us a negative inside the bracket times a negative. That ends up being positive. So you don't even need to necessarily do all of the work, all of the answers. You just need to get positivity, negativity. And we're going to work across for one factor. What happens at -4? It becomes 0 because inside your bracket is 0. What happens in between -1 and -4? Let's pick -2. You have a positive inside the bracket and negative outside. That's negative. What happens at -1? You still have a positive inside times a negative. That's negative. What happens at, let's say, test value of 0? You have a positive times a negative. That's negative. And the rest of these finish out as negative for the same reasons. And then we go down to our next factor. This one's even easier to work with because there's no value, there's no multiplier out front. So to the left of -4, so negative minus a positive, a negative and a negative, that's going to be negative. -4 makes -6, so that's negative. Anything negative here is going to be negative. We can take a test. If you're not sure for this next one, you could take a test value of 0. Well, 0 minus 2 is negative. What happens at 2? It becomes 0. And then greater than 2, we have positive. Okay, so you can see in these simple cases, it just changes. It goes from positive to 0, and the rest are negative. Negative, 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 0, positive. It doesn't always go that way, especially when you have combined. So if you just have one factor, it will always work that way. But when you start to combine factors, like down here, it doesn't. But that row is easy to figure out as well. So our next factor, if we put a -5 in there, we'll have a negative number. If we put a -4, we'll be negative. Anything between -4 and -1 will be negative. At -1, we'll hit 0. And then we're looking at positives for the rest of the chart. All right, the last row is where we really get our final answer from. So we've put this all together. We found out for each factor when each factor is positive or negative. So now really all we're doing is we're saying, okay, in this interval, x less than -4, the first factor is positive, the next one is negative, the next one is negative. What do we end up with? If we have two negative factors, we're going to have a positive result. Positive product. A positive times a negative will be positive. Okay? In the next column, at x equals -4, we're going to have 0 times a negative times a negative. Well, anything times 0 is 0, which makes sense because -4 is a root of the corresponding equation. In the next interval, we have a negative times a negative times a negative. All of our factors are negative in that interval. 3 negative factors results in a negative. The next one has a 0 in it, so it's 0. The next column has 2 negative factors, so it's positive. The next column has a 0 in it, so it's 0. And the next column has 1 negative factor, which makes it negative. And now we simply analyze what intervals and what columns actually result in meeting the requirements and satisfying our original inequality. Well, we're looking for any value less than or equal to 0. So I would just go by underneath with maybe a different color or the same color, depends on what you're doing, and anywhere that I have a negative and a 0, I'm saying, yeah, that column works. So anywhere I see a negative or a 0. So therefore, the solution, it goes from -4 to -1, and it includes -4 and -1. So we've got -4, x is greater than or equal to -4, but less than or equal to -1. Or the other interval that works for us is x is greater than or equal to +2. So again, maybe a little bit tedious setting it up with your intervals, but once you have it set up, it becomes quite simple. You're only ever looking at one factor at a time. And then when you put it together, you're not even doing any algebra. You're just looking at how many negative factors you have, and then double check your inequality. Do you include zeros or not? In this case, yes. But also when you're setting up the chart, make sure you include a column for each of your roots. Okay? Because zeros are important as well, especially in this case. Example 3, we get a somewhat real-world problem that we're going to solve using a factorable polynomial inequality. So we have a rectangular in-ground pool. It's going to be installed. The engineer overseeing the construction project estimates that at least 1,408 cubic meters of earth and rock needs to be excavated. That's a pretty accurate estimation. What are the minimum dimensions of the excavation if the depth must be 2 meters more than 1/4 of the width, and the length must be 12 meters more than 4 times the width? All right, let's digest this. What's given? We're dealing with volume. Volume is length times width times height in a rectangular swimming pool with uniform depth. We're also told that the volume equals 1,408 cubic meters. And we're also given some information about the dimensions. We're told, and now we need to be able to translate from words into algebra. We're told that the depth is 2 meters more than 1/4 the width. So we've got height for depth is 2 meters more than 1/4 the width. So we've got 1/4 of the width plus 2. We're also told that the length is 12 meters more than 4 times the width. So we've got length equals 4w plus 12. What other things do we know are true about this? Well, we know that each of the dimensions has to be greater than 0. Greater than 0, otherwise there would be no volume whatsoever. If any one of the dimensions were 0, the volume would be 0. So we know that h is greater than 0, L is greater than 0, and W is greater than 0. Okay, so from here we can set up an algebraic equation that reflects the information that we've been given, and we're really just starting with this. Volume equals length times width times height. We have expressions for h in terms of W and L in terms of W. So what we have is volume equals W as one factor times, let's say, the height, which is 1/4 W plus 2, times the length, which is 4W plus 12. What we're going to end up doing is expanding this, getting an expression for V, and then we're going to try to factor it and find our solutions. Okay, so our first step is going to be to expand it, which I'm not going to show the whole expansion. I'm just going to write the answer, but it's pretty straightforward. You have 4W times 1/4 W, which is nice because it comes out as 1, and you end up with just 3 factors of W, which is W cubed. And the rest of it is 11W squared plus 24W. So that's our expression for volume. Now, the reason that we need to expand this is because we actually have a value for the volume. And what happens is now we know, so if volume equals that, then that means that 1408 equals w cubed plus 11w squared plus 24w. But we can only factor or solve this if we have the equation that's equal to 0. So we end up subtracting 1408 from both sides in order to get an expression with 0 on one side. So we've got w cubed plus 11w squared plus 24w minus 1408. Now that is specific to the pool that we're dealing with, and it's something that we can then factor. Factoring this results in, if you use the factor theorem, integral factor theorem, you will get a factor of w minus 8 and the quotient left over will be w squared plus 19w plus 176, and that is the inequality that we're looking for, is that is greater than or equal to 0. This trinomial can't be factored any further, so we just have to test. We have to go back and look at the cases. We need this to be greater than or equal to 0. By the way, I'm not showing these in-between steps. You know how to convert into a, you know how to expand this. You just have to be careful, and you know how to now divide big polynomials. So you just have to be careful. But you will get that this trinomial doesn't factor any further. So from here, we're going to test our cases.
Are we supposed to come up with dividing it by w?
So all we need to do, if it's going to be greater than or less than 0, then case 1 would be both of them are positive or 0. And case 2 would be both of them are negative and 0. That's the only way you can come out with a positive or 0 answer. So either this and this, or this and this. So we'll work that out. This one's easy. Add 8 to both sides. W is greater than or equal to 8. And over here, this w squared plus 19w plus 176 is greater than or equal to 0. That is true for all values of w. All of them. All of them in the whole world. True for all values of w. What's one way that you can know that? Well, if you put in a positive value, then obviously it's going to be positive. If you put in 0, you're going to be left with 176, which is positive. If you start going into your negative numbers, the bigger that your negative number you put in, you're actually going to square it into an even bigger positive number. So the only term that can actually end up with a positive value, sorry, a negative value, is this middle term. And it never can grow big enough to overcome the two positive, always positive terms. Okay? The closest you would get is probably multiplying by -1. The closest you would get is multiplying by like -4. Anyway, that's irrelevant. It will always be positive for all values. So that means the solution for case number 1 is W must be greater than or equal to 8, because all values would not satisfy this inequality. And then in our second case, for negative values, we use the same. We've got W is less than or equal to 8. And now, by the same logic, if this expression is always positive, can it ever be negative? No. Can it ever be 0? No.
Sorry, I missed it. What's up with the true for all values of FW? Like this.
Okay, the question is, what are the minimum dimensions? We know that W is always going to be bigger or equal to, greater or equal to 8. So its minimum dimension would be 8 meters. So the minimum dimensions, W equals 8 meters would be the minimum width that it could be. What about height? Well, we would just sub in 8 in our equation for height. So we'd have 8 over 4, which is 2, plus 2. We'd have a minimum height of 4 meters. Should probably just write that. And for our length, we had 4 times W, which is 8 plus 12. So that's a length of 32 plus 12 is 44 meters. Which is a really big pool.
It's a really long pool.
412, 4 times the width. Yep. It's good. It's a really long pool. There you have it, minimum dimensions. Applying all of the things that you know and love about algebra.